We'll get going. Yeah, so welcome everybody to our latest homeowner webinar. This evening, we're going to be chatting about solar panels and battery storage for home resiliency. I'm Ryan Coleman, and pleased to be joined by Sue Chung from Energy Save New West. And we will introduce our keynote, Ben Guiducci, here momentarily. We've been developing this series. We've done a couple on heat pumps. We like to both do kind of industry development directly with the contractors and builders, and now we're venturing into doing some more support webinars for homeowners who are looking to do energy efficiency upgrades and performance related upgrades for their homes. So really pleased to have folks out here this evening to learn more about panels and battery storage. Just a couple of housekeeping items. We are recording this, so if you want to be on camera, you can be on camera. If you don't, you don't. We want to make it available. We had quite a few people who said they were interested, but unable to attend this evening. So we're going to make this available through our e-newsletter and on our website. Please remain muted unless you want to raise your hand to ask a question. I think we want to try to do the presentation. Ben, is that you'd like to just do the presentation and then we can do Q&A at the end, or do you want to take questions as we go?
I'd prefer to take questions as we go, Ryan,
Okay.
so that we don't lose the essence of what's
Sure.
being asked. Yeah, and if you'd be willing to help me by
Yeah, I can facilitate.
looking for raised hands, and so because
Totally.
it's difficult for me to present and watch that at the same time.
Sure, that sounds good.
Yeah.
Okay, so if you wanna ask a question, you can either raise your hand as Ben was saying, and then we'll call upon you. You can unmute and come on camera if you want, or if you want to just put your question in the chat, then Sue and I can facilitate that through the questions as well. All right. In terms of agenda, so we'll do a welcome here to Ben, who's joined us. He's going to do the keynote presentation on solar panels and battery storage. Ben is joining us from Kamloops this evening, where his company Riverside Energy Systems is located. And then Sue is going to share a few updates. We just recently announced or implemented this past year the solar PV and battery storage rebate program in the city of New Westminster. So we want to just provide some updates on that, as well as we've got a new resource to help homeowners with frequently asked or local residents with frequently asked questions and things. So we're going to provide that, and then you'll see it in our e-newsletter, which will be released tomorrow. And then we're going to close off. All right, so let's get started. So Ben Guiducci is the director of Riverside Energy Systems. He's actually been helping us out with some of the solar PV and battery storage industry development through Energy Save New West, specifically for industry. So we're really happy to have him talking tonight more specifically around the homeowner, local resident side of things and those that are purchasing systems. He's got a ton of background and subject matter expert in this area, worked for BC Hydro for over a decade, and then has been a faculty member at Thompson Rivers University in electronics and engineering, and then joined Riverside Energy Systems in 2009. Had keen interest in all things solar and storage and electric design with regards to zero energy buildings. And he's been involved in system design and installation and training business professionals for the last 16 years. He's an electrical engineer and a registered professional engineer in BC. And he's also devotes some time to supporting high performance buildings and training for builders and trades through BCIT's Zero Energy Building Program. So really pleased to have Ben join us this evening and provide the keynote.
Yeah,
Over to you.
Yeah, thanks, Ryan. Can you hear me okay? And are you seeing my full screen slides?
You're good to go.
Excellent. Yeah, I'm going to be speaking tonight about solar and storage and home resiliency, and an overview of how I'd like the thing to flow tonight is we'll look at operating principles and some of the motives that homeowners might have around resilience that involve solar and storage functionality. I'd like to talk a little bit about some of the trends and emerging technologies and how things have changed really quickly in the solar industry in the last few years and why. Um, we'll look at solar effectiveness in BC's Lower Mainland. Um, there's a lot of skepticism around how well solar works in BC or Canada as a whole, and I'd like to put some of that skepticism to bed and bring some realistic science, hard science to that. We'll look at some of the key considerations for doing solar and storage projects, the sort of approvals, permitting processes that you can expect, and rebate incentives that are available. I also want to look at some case studies to help you better understand motives that other customers around BC have had for solar and the project economics around those and how they might translate to similar projects in New West. And then lastly, I want to look at some good guidance for overcoming some of the most common challenges and pitfalls so that we can achieve best outcomes. So what I'll start with then is a little bit about resilience. Like uh, some of the most common motives would be homeowners that want to lower their grid consumption in their existing home. They're not necessarily, doing insulation or air tightness or space heating and cooling upgrades, but they want to just quickly reduce their dependence on grid energy. Solar can do that for us. And then there's another other class of homeowners that are maybe undergoing their homes are undergoing electrical energy retrofits where they're retiring natural gas furnaces and hot water tanks and replacing them with electric HVAC equipment, potentially even with some envelope upgrades. And solar can help with that as well. So the motive there would be to use solar to lower the ongoing grid consumption and operating costs for electrically retrofit homes. And then there's some examples where people are maybe building a new home and are looking to achieve a performance certification like net zero or a living building challenge. They're two different certifications, both of which require that the annual energy production of your solar system exceed the annual energy consumption of the home. And we'll look at that a little bit more later. And most recently, we're finding that people are interested in using storage and so with solar to reduce their home's vulnerability to grid events. And so that'd be doing things like being able to back up some critical loads, essential loads during outages, or being able to use storage and solar together to leverage and mitigate some of the increased costs around evolving utility rate structures. So those are the main motives we see for the use of solar and storage in making the operation of a home more resilient. So I thought we would look at how solar works under the new Westminster electrical utility net metering rate. It's called Rate 500. Under that rate structure, single family dwellings um, would have this sort of an architecture for solar system. So the solar system would use solar panels which produce DC electricity to drive a solar inverter, which converts that DC into AC 120, 240 for use in your home. That power is injected into your electrical system, quite often, quite commonly, the main service panel. And and then what happens is the loads in the house will use the solar energy being produced first if the sun is shining, say during daylight hours. And if they need more than what the solar is providing at any particular moment, the shortfall will flow in from the grid, energy inflow from the grid. And during moments when the solar system might produce more power than the home needs at any particular time, that the surplus power will flow out to the grid, and that accumulating energy outflow is also measured by the net meter. And so the net result here is that while the solar system is operating during daylight hours, it will reduce how much energy the home needs to purchase from the grid, and it might actually produce more than the home can use, which will outflow as surplus to the grid. And so the idea here is that the net meter has two registers. One measures energy inflow, the other one measures energy outflow. And under the New West model, uh, a single family residence pays 13.44 cents for each kilowatt hour of energy. When energy outflows, it's stored in the grid for later use. So if it say there's outflow during the day on a sunny day, well, your house might use that energy that the grid has stored on your behalf, might use it at night when the sun isn't shining anymore, or it might use it the next day. Um, the the idea here then is at the end of each billing cycle, you will get billed on the difference between what flowed in minus what flowed out. And then during billing cycles where you might have produced more than you might have outflowed more than you inflowed, then that will create an energy credit that is carried over into the next billing period. And so the idea, for example, if you have a lot of solar, this would allow you to generate, let's say, a lot of electricity during the spring, summer, and fall months so that you have a surplus going into the winter, and then that surplus gets drawn down in billing cycles during the winter time. So if essentially the grid is acting as a battery to store any surplus energy that you outflow for you to use later. And the key thing here is that energy that flows out has the very same monetary value as energy that you would flow in that you'd have to purchase. It's a one-for-one exchange. With systems like this uh, that don't have battery storage, what happens is when the grid goes down, the solar system also shuts down and it becomes inactive, and then it'll come back to life when the grid power returns. So it's not able to help us during an outage. Now, if we add battery storage, so now we have the same solar array, but now we're using battery storage and a hybrid inverter, and the difference between the hybrid inverter and the solar inverter is that the hybrid inverter is able to operate from battery when the grid is down. And so the idea here, by adding the battery energy storage system, our grid connected system now not only reduces how much energy we need to buy from the grid and stores and uses the grid to store energy for us later, it also can provide extra functionality. And the key one is that it's able to back up essential circuits, for example, refrigerators, freezers, maybe your computer, internet equipment for staying connected to the world, and maybe some sparse lighting and outlet plugs, so that you can ride through grid outages for those essential loads. So it's a resilience thing. And then in utility jurisdictions where uh, there's other things like potentially time of use rates, which New West doesn't have. Battery storage can also help uh, mitigate and leverage those rates. So, so when we add battery storage, the key thing here is that the system works as before, but with battery storage, it has additional functionality so that when the grid goes down, um, the essential loads are still supported. Now, moving on to reduced consumption for existing homes and electrification retrofits. As we know, when a home is more electrified, perhaps through the use of electric hot water tanks or even hybrid hot water tanks that have heat pumps in them, heat pumps for space cooling and space heating, and the the addition of, say, EV chargers. And then, all electric cooking versus natural gas cooking. Well, what can happen is that household is suddenly drowning in additional energy consumption, which electricity consumption, which wouldn't have been there prior to the retrofit. And thankfully, solar PV can help mitigate that. It'll reduce our dependence on grid energy. So some people will move in that direction. So they'll add solar to a new home or to an existing home just to reduce their consumption, or they'll add it when they're electrifying the home because they know they're going to have increased consumption. And then the one I was mentioning earlier is uh, grid resilience for backup of essential loads. So this shows the uh, the battery-based solar system with the grid out. And so if all of your essential loads are intentionally connected into a backup subpanel, so as I mentioned, fridges, freezers, other critical loads, even in the absence of grid power, those loads can remain alive, and the hybrid inverter will use the battery storage and the solar generation to keep those loads alive um, as long as possible. And as it turns out, it's even possible to add a backup generator to help to ride through the longest outages that could occur during forest fires or flooding events or other climate related uh, disasters that can take the grid down for long periods of time. Brian, are there any questions yet that are coming in or?
Nothing yet, Ben.
Oh, okay. Well, then I've either put everybody to sleep or it's crystal clear. I'm hoping for the latter.
All good.
Yeah. So some trends in the solar marketplace in the industry in BC. What's happened is that the cost of solar uh, globally has fallen much more quickly than we'd anticipated a few years ago, and much of that is due to global markets, normalizing to solar in many countries, adopting it very aggressively. Lots of competition in manufacturing around the world, and significant improvements, not just in the solar technology itself, but also in manufacturing methods, particularly for solar panels. And then coupled with that, the cost of grid electricity has risen a lot faster than many many people thought it would. And this is related to utilities, big utilities, for example, like BC Hydro, needing to spend considerable capital, upgrading aging infrastructure, and then new projects related to electrification, such as Site C, and other generation facilities that have come online in the last number of years. Influences from the BC Utilities Commission, and also some of the rates that have come along. Like for example, BC Hydro has a two-tiered residential rate, and I think there's also a tiered rate in New West structures. But those two actions, the falling cost of solar and the rising cost of electricity, had put us on this quest for what we call solar grid parity, where it costs the same to buy electricity from the sun as it does to buy it from the grid. And so in 2023, the BC Sustainable Energy Association um, involved some researchers in trying to project when grid parity would happen, when the falling costs of solar would cross the lines with the rising utility rates. And it was projected to happen somewhere in 2019 to 2024. And it turned out it happened 3 or 4 years, well, actually quite a few years sooner. It turned out for BC Hydro residential customers, it happened in 2016. So if there's um, people out there and in in BC, if there's British Columbians out there that are thinking that it's still cheaper to buy energy from the utilities than it is to buy it from the sun, it's not quite the case. It's actually cheaper to buy it from the sun, but of course there is an upfront capital cost barrier, and that's one of the things that's held solar back. In fact, the idea of residential solar as an investment, that concept is very new in BC. It's not until just the last few years that people have really started to view it that way. And reasons for that, include that there's not all that much public awareness at how significantly solar costs have fallen. Um, and then historically, rising energy costs have been more of a concern to industries, to commercial customers that are running businesses and industries than it has been to residential households. And it's probably only in the last 8 or 10 years that residential customers have really started saying, "Hey, I'm feeling the pinch." But let's say 15 or 20 years ago, um, I never, we never heard that from homeowners. We only heard it from people that were operating sawmills or drugstores or things like that. And then in our marketplace for homes, it seems that aesthetics often trump function and operational features in residential markets, and that's starting to change, which excites me. Um, so for 10 years ago, for certain builders would be more likely to promote granite countertops in a kitchen or plank flooring than they would be to promote solar. But now more and more builders are promoting solar with their clients. Another thing is historically, there haven't been incentives for solar other than the fact that in BC, um, solar systems are not subject to provincial sales tax. So the only tax is GST. Uh, it's really only in the last 5 or 6 years that we've seen significant incentives available. First, I believe in 2021 with the Greener Homes program, which has now been phased out, and most recently in 2024 with rebates becoming available from BC Hydro, which have now been extended to New West customers as well. And we'll say a little more about that later. Uh,
Ben,
yeah.
yeah, your last query, I guess, encouraged a few questions.
Oh, okay.
Maybe we can quickly pause. They came in through the chat.
Sure.
The first question came from Balpreet, and it is there a limit to how much energy? Uh, oh, oh, Sue's answering some of these.
Oh, okay.
All right. Balpreet, Sue's giving you the answer. We'll just jump to Trevor's. I don't know if you talk about this, but I know you've done some work on this. The question is I've heard BC Hydro is moving away from one-to-one net metering, paying the individual producer less per kilowatt hour. Does New West utility intend to follow in that direction? Oh, yeah, Trevor, maybe you can comment on BC Hydro, and then we can just defer on the on the New West utility.
Sure. Well, thanks for that question. Yeah, recently on July 1st, BC Hydro eliminated net metering and they're using net billing instead. And just to answer the question well, we'll go back to this slide. Um, in with net billing, you're using the very same configuration. It's just that energy that's flowing out to the grid is valued at a lesser monetary value than energy coming in from the grid. That's the big difference. So in the BC Hydro case, they're only paying their customers 10 cents for kilowatt hours outflow to the grid. But my understanding is that the New West model is net metering at the moment, and I
Yeah.
wouldn't want to try to guess what the future holds there. So
Yeah. exactly. There's no change there.
Yeah, no change. Yeah. Okay.
And then Gavin's got a good question. I think I can maybe answer this one. Gavin's one of our, there's actually a few subscribers been in our, we've had this urban solar garden that we started, which is a community-based solar. We've got two gardens, one on Queensboro and one at the electric utility works. And Gavin's one of the folks who was one of the people who was
Oh,
an early subscriber and supporter.
good
Uh,
for Gavin. I love
as
early adopters.
as well as Bob Petrusa, who's also on the in the meeting, was also one of the people who's been involved as well. So there's been some solar supporters there from the early days. Um,
Kudos to the two of them.
yeah. So Gavin's question is around New Westminster is increasing housing density with multifamily units. Solar panels are not necessarily suitable for them. We should have a community solar project. Would we have a community solar project? Would it not be better to add to that? So what I can say, Gavin, is we have looked at some other underutilized assets with the city and exploring opportunities to maybe add to the urban solar garden again. And we will update as if some of those projects materialize. All right, that is all. That's all. Oh, sorry,
Okay.
Brendan. There's another one.
Okay.
Folks on there. Very good.
So Brendan's question was answered, or
Just he was just mentioning he was one of the early adopters
okay,
helped develop the market. So there's a few of them out here who've been supporting.
excellent. Yeah, excellent. Um, so to just look at how net metering has worked for BC Hydro, as we can see here in the early days or the early years of adoption, the subscription levels were quite low. And then in around 2020 and 2021, there was incentives that became available through the Greener Homes program, the federal Greener Homes program, and things began to take off. And my understanding is that in February 2026, BC Hydro had 17,000 uh, customers connected using net metering, and which is now called self-generation. And that I believe it turns out that 98% of those were solar installations, with a tiny number of wind and microhydro projects. Yeah, another thing that's changed in the industry is net zero thinking. So traditional thinking around net zero building, when net zero first started to be a thing, was that solar was very expensive, and so the way you would do a net zero home is you would do all of the building envelope high performance upgrades and the HVAC high performance upgrades first. And then if you had any money left over, you might add solar last. And if you didn't, you just settle for solar ready. And of course, what's happened in the last 10 years with the cost of solar having fallen so dramatically, it's now like provincial average is about 280 a watt for residential installation compared to $6 or $7 a watt back in 2010. What's happening now is builders are realizing, hey, the envelope and HVAC improvements are pretty expensive, so why not be more modest with those improvements and add solar first? Because solar is so cheap, we can add a little more solar to compensate for the fact that the envelope and HVAC are not, at the extreme high end of performance. And so what's happening there then is people are starting to see that solar is not just for net zero homes. So it's not a net zero or nothing proposition. They're starting to see solar as a PV investment that could be viable, um, for any home, not just a net zero home. So this is a real change in the builder paradigm. Uh, Other things that are coming down the pipe that I think we're going to see in the not too distant future, because they're happening now in a number of other countries around the world, is the notion of including EVs in the mix. Um, so the whole study and this area of technology is called V2X. V2X means vehicle to anything, which could include vehicle to grid, vehicle to home, vehicle to solar, vehicle to BESS. And what these systems can do is it allows the EV to be part of the battery storage resource that the home might use for grid resilience. And it also allows for example, the solar system or the battery storage system to charge the EV when the grid is down. So, it's very interesting interaction and powerful interaction that I think we'll see coming into the Canadian market in the next few years. It turns out the technology is already available to do all these things. And what's standing in the way is that certifications for this kind of V2X equipment and electrical code and utility policy has to catch up to allow these configurations to be viable in British Columbia. But it'll happen, um, hopefully sooner than later. Another one, and at one time this is like science fiction, uh, where utilities can take control of distributed energy resources. So, distributed energy resource could be a solar system on your rooftop. It could be a battery storage system in your garage. It might be your EV if the EV is connected in a V2X configuration like this. And using distributed energy resource management systems, which are basically computer systems that can communicate with solar and battery storage systems out there in the grid, the utility is able to control those resources to advantage, to call on rooftop solar, to call on customer battery storage at times when the grid is needing the energy desperately, like maybe peak demand hours, like say around dinner time. And a DERM system is able to also create what's called virtual power plants, where it can aggregate, hundreds of solar installations around the province and speak to them as though they were one large solar plant. Now, of course, this all has to be allowed by customers, but it is coming, and it's happening in other parts of the world. And in fact, BC Hydro is currently doing it on a small scale. There's a BC Hydro Peak Saver Demand Response Program, which uses home batteries from a company called Iguana. And Hydro is just coming to the end of a program where they were providing these battery storage systems at no charge to customers that lived on distribution feeders that were compromised or overloaded, particularly in the wintertime. And so my company, Riverside Energy Systems, has installed quite a few of these in the Kamloops area on a compromised feeder under this BC Hydro program. And the way it works is when the grid is having a problem, it's say experiencing a peak and it's having difficulty on controlling voltage on a particular feeder, it communicates with these batteries and tells them to start discharging energy into the home to reduce the demand on the feeder. And so this kind of technology, smart grid, it's just around the corner. It's happening now on a small scale, and in the next decade, this sort of thing is going to grow explosively. Now, a really important thing to understand is solar PV effectiveness. It basically answers the question, how well does solar work, in my area, in my town, or my village, or my particular the location of my home on any particular point on the earth. And so this solar PV effectiveness is a universal metric that we use all around the world for comparing how effective solar is in any particular location. And what it tells us is it tells us if we were to deploy 1,000 watts of solar, say for example, two 500-watt solar panels, ideally oriented, the ideal orientation and tilt, how much AC electricity would that solar system harvest over the course of a 365-day year? And so it turns out that um, the BC average is about 1,000 kilowatt hours for every 1,000 watts of solar you deploy. You'll get about 1,000 kilowatt hours a year. New West ranges from about 940 to 1030, dependent on your roof orientation. But ideally orientated, it's around 1,030 kilowatt hours a year. Where I live in Kamloops, it's about 1,200. Kimberley, BC, which is a better solar area, is about 1,300. And and if you were to ask the question, well, how does this compare to other parts of the world? Well, it gets better as we get closer and closer to the equator. But if we talk in terms of other aggressive solar adopters, for instance, Germany, who was the world's most aggressive solar adopter for many years, they lost that title, I think, about 8 or 10 years ago to China. But in Germany, that number is about 850. So that's quite a bit less than the BC average. So so if people say to you, "Hey, solar doesn't work that well in BC," um, I mean, it's true. There's parts of BC where it might not work well, and depending on how your home is oriented, what directions the roofs face, and how shaded they are, they might not work very well. But in general, solar works better in BC than in some of the countries that are adopting solar most aggressively. So the reason we're not using it more is not because it doesn't work. It's for other reasons. The other thing I wanted to point out is that, when I say that um, New West might harvest in the order of 1,030 kilowatt hours per kilowatt per year, you need to realize that each month is not as good as all the others. Like the highest production months are going to be between March and October, with May, June, July, and August being the highest production months. So the production does vary seasonally, and hence my reference earlier to solar systems on a rooftop under net metering that produce a lot of energy in the summer months, maybe overproduce in the summer months. That energy can be drawn down to help cover load in the winter months when your solar system is not going to be working as well. So solar effectiveness depends a lot on things like your latitude and longitude, historical regional climate, uh, uh, and weather, as well as atmospheric conditions like smoke and dust and smog have a big impact. It depends a lot on the orientation of your array, like the compass bearing, the azimuth, and pitch. Generally, south orientation is the best. But being facing directly south is not as critical, particularly for lower pitched roofs. So the flatter your roof is, the less important it is that it be south facing. And we can still get very reasonable production results for east roofs, west roofs, or anything southerly in between, particularly for lower roof pitches. A big factor that can hinder PV effectiveness is shading. How accessible is the sunlight to your rooftop? So we've got techniques for quantifying and assessing that and accounting for it. And shading can be from far objects like mountains, buildings, trees in your neighbor's property, or it can be near shading like self-shading by chimneys, plumbing stacks, hips, electrical masts, dormers on your own roof, or trees, on your own property can cause near shading. And so the honest thing to say is that not every home is going to be well suited for good rooftop solar performance, but a reputable solar provider will have the tools and the skill to assess all of these factors and advise you responsibly and establish realistic expectations for your system and confidence that you're making a good investment. So, if people try to twist your arm and say solar works great, you ought to do it. Well, it might work great, but you got to do some homework to make sure it's going to work great. So, in terms of how do we estimate these harvests? Well, there's a number of expensive modeling tools that solar practitioners use that homeowners wouldn't generally be able to afford. But there's also some great free resources. There's two here from Enercan. And I hope later, Ryan, that the PDF of this deck will be made available to people that are on the call so they can use these links. I'm hoping that's the case. Alternately, I can provide them later and you can email them out.
Yep. Yeah, we're going to make the slides available and post for the website as well.
Oh, excellent. Okay. And then one of my favorites is a, a free solar modeling package that was developed by the National Research Energy Lab in the US called PV Watts. It's completely free and it's very powerful. So, a motivated homeowner might want to download that and play with it. Um, so I don't think we can overemphasize the importance of being certain of good solar analysis access and analyzing the shading of your potential site. Like this is an example of a bad site which is very heavily shaded by a tree right in the customer's yard. And the solar provider did not warn them that this would be a problem, which was disappointing. Um, this was not in the Lower Mainland. It's a city in the Thompson Okanagan. Um, Now, a reputable solar provider will assess shading before they propose a design, and there's various tools for doing that. There's solar cameras which will capture horizon shots that show all the shading obstacles and calculate sun paths and actually calculate, how accessible the sun is based on your exact location. And it'll actually show you which obstacles are creating the most obstruction. So these are two examples. The one on the right and the one on the left are two homes that were basically side by side. So the one home had relatively compromised solar access, an annual score of only 79%. So effectively, 21% shade compromised. And the home next door, literally less than 100 feet away, was 94%. So this just shows that you can't assume that every home is going to perform equally as well. It needs to be carefully assessed. Um, and then for assessing near or self-shading, providers will use 3D models, and some of the expensive tools we have available to us can access LiDAR bases that will, show trees and 3D images of the rooftop. But in situations where that's not available, solar providers can use a drone photogrammetry where they'll fly a drone over the house and it'll capture a few hundred images from which a 3D model can be generated. And this is an example of a system for a home we did in Kamloops where using that analytical tool, we're able to show clearly how the gable on this west gable jutting out to the west actually will shade this west-facing array on the adjacent roof in the afternoon. And it'll also calculate the reduction in solar harvest that you can expect as a result of that shading. So there's tools out there that will let professionals assess this confidently, so you don't have to be guessing at how badly shade compromised your site might be. Now, transitioning to a new topic, and that is, how solar affects your building. It turns out that solar has impacts on building systems in the house. So it'll impact your electrical system, and we'll look at that here in a minute. It will impact your roof, and so in particular, depending on your roof design, your layout, orientation, pitch, that will affect the design that might be best suited. Um, so how much space is available as well on the best oriented roof facets. But on top of that, when you add the solar arrays, It'll create additional loading on the structure, and it'll create wind uplift. And these things have to be carefully considered so that we don't damage the roof structurally, and so that we don't damage the roof membrane integrity, so it remains watertight. So that's really important. And then there's impacts around equipment placement. So inverters, disconnection means for shutting the system down, and something for rapidly shutting the system down. It's called a rapid shutdown initiator, which firefighters would use if they arrive to your site and there's a solar system on the roof. And then lastly, we have to be concerned about how we're going to penetrate the building envelope for routing cables. Are we going to go through the roof? Is there a second floor wall we can go through to reduce the likelihood of roof leaks? Um, or do we go through a gable? Uh, so these things have to be considered. Ideally, we minimize the envelope penetrations to keep envelope integrity, at the forefront during an install. How are we for questions, Ryan?
We are all good. No, no,
How
no new
much time
ones.
do we have left? About
Time
another.
check, we're at 7:20.
Okay, so we have another 40 minutes or so.
Yep.
Yeah.
Yep.
Okay, excellent. So how does a solar system affect your electrical service equipment? Well, um, usually a solar system on a residential home will tie in um, to your main service panel or potentially a sub panel through a dedicated solar breaker. And now, as soon as we've done that, we now have two sources of electrical energy that are driving this panel. So um, we've got the grid here, so that's one source of energy, and then we've got the solar system also driving the panel as a second source of energy. So when there's more than one source of electrical energy driving an electrical panel, there's a rule in the electrical code that kicks in that causes the need for additional caution. And the concern is that we don't want to be overloading the bus bars in the solar panel or in the service panel where the breakers uh, clamp or bolt in. Those bus bars could potentially get overloaded if there's two sources of energy under certain scenarios. And so what I wanted to show you is this conundrum, where if we apply this code rule, uh, the solar breaker and the main breaker cannot add up to any more than 125% of the bus bar rating. Well, what does that mean in English? It means that not all 100 amp panels or not all 200 amp panels are created equally. So what I've got here in the diagram is I've got two different 200 amp panels, which might seem like the same thing to the untrained observer, but the one on the left, the bus bars are only rated for 200 amps, whereas the bus bars on the panel on the right are rated for 225 amps. They're more heavy duty. So even though these panels are both 200 amp panels with 200 amp main breakers, they're both 200 amp services. The panel on the right, because of this extra caution we have to apply in the presence of more than one energy source, the panel on the right can actually handle 60% more solar than the panel on the left. So if this, for example, was a new build and we needed to be able to connect 12 kilowatts of solar to accomplish net zero, and the electrician, not knowing any better, installed a 200 amp panel with only 200 amp bus, we'd be stuck. We couldn't install that system, and the only way forward would be to either relax the expectations and say, oh, well, I guess we are not going to be net zero after all, or we tear out that panel and put in one with a heavier bus, which of course creates extra cost. And so this snag comes up over and over again, and it illustrates the importance of electricians that are going to be responsible for the service equipment uh, collaborating early on with the solar providers that are designing the solar system to make sure that the panel into which they're going to connect a solar can handle the amount of solar that the client intends. And I don't want to tell you how many times we've run into this problem because people weren't communicating. In terms of structural impacts, um, it turns out that a roof attached solar array can add 2.5 to 3.5 pounds per square foot of additional dead load, which is not too much of a big deal. But what happens if that ends up being snow covered and the snow doesn't slide off, if the snow is trapped, we can end up with significant point loads that are transferred into the roof through the solar racking anchors. And this at times can be problematic. So, for new homes, builders can make use of solar ready trusses that are manufactured to Truss Plate Institute of Canada standards to handle these additional loading considerations, and then it's not a problem. If it happens to be, you're putting solar on an existing home or a retrofit uh, situation, then the structural sufficiency of the roof has to be confirmed, and that can often involve having to call on a structural engineer to confirm that structural sufficiency and to recommend remediation if the roof structure isn't strong enough. Now, in terms of how solar can anchor to a roof, it can be done with flashed anchors that secure into the roof decking and the trusses, or with flashed anchors that secure into the roof substructure, not necessarily directly into the trusses. If it's a standing seam metal roof, we may be able to use standing seam metal clamps. And if it's a flat roof, we might be able to do a ballasted system. Uh, the anchoring methods, the strategies that are going to be used, have to be reviewed and finalized, early in the discussion, particularly, if it's new construction, so that the solar installer, the builder, truss designer, structural professionals, and the roofing contractor are all happy with the anchoring strategy, so we don't wind up with additional risk that we hadn't intended and that we don't end up voiding new roof warranties. So this is what the hardware looks like. This is an example of a deck attached style anchor. And these are easily installed after the roof shingles are on. They fasten into the sheeting or top truss cords using multiple small screws, which will not crack the top truss cord. If we use flashed anchors like this one on the right that attach into the substructure, then they will not anchor into top truss cords, which could be damaged. Instead, they'll anchor into structural blocking that might be put between the trusses, or potentially sistered 2x4s, which are attached to the side of the trusses, but not into the top truss cord themselves. Here's kind of a blow up of what these deck attached anchors look like. So there's a anchor plate which goes down over the roofing and attaches with multiple screws into the sheeting and top truss cord with a stud, a threaded stud, which is watertight. The flashing goes up under the course of shingles above, two courses above, and it works nicely for retrofits. It's easily added on an existing roof. And so how these go down is something like this. This is an example of an installation in the Kamloops area on an asphalt shingle roof. So here's the flashed anchors that I'm talking about that have attached into the decking with multiple screws. Then the solar rails attach to those anchors using L feet, which are attached with stainless steel hardware into the into the flashed anchors. And then once the rails are down, then the solar panels attach to those rails, and they're held in place with clamps on the ends and in between the rows of modules. They're mid clamps, and they basically bolt down from above and hold the modules in place securely on the rails. So as I mentioned earlier, this kind of an assembly adds in the order of 3 pounds per square foot. And then if it happens to be snow covered, the additional load from the snow, it's transferred into the roof through these anchors. Yeah. Any uh, any questions so far, Ryan, on this?
Nope, still good.
Okay, excellent. Uh, in the event that a home has a standing seam metal roof, it may be possible to attach the racking system to the roof using standing seam clamps. There's a multitude of standing seam clamps. They're made of stainless steel that and aluminum that are intended for basically every standing seam roof profile under the sun that's available in North America. To make this work, though, the the roofing gauge needs to be at least 24 gauge or heavier. Lighter than that, the roofing material can be damaged when we tighten the set screws. So the way this works is the set screws tighten onto the metal seams, and those become the anchoring points against uplift and dead load, and there's not actually any anchoring penetrations through the roof itself. So it's a great way of avoiding penetrations if the standing seam roof approach has been used. And then lastly, for flat roof situations, ballasted racking is often a good solution. The strategy here is the racking product will require a calibrated array of solid concrete blocks that you can see are laid out here in a pattern that will have been specified by a racking engineer that is analyzing the wind loads for that particular site, and then they will provide stamped assurances that their ballast plan will withstand the local wind loads. This is a great means of avoiding roof penetrations, and with flat roofs tending to experience drainage problems, intrinsically, knowing that your solar racking system is not penetrating the membrane can be an advantage. But uh, of course, the structure or the blocks that were used here in the engineered ballast adds more structural dead load. So this needs to be reviewed. So not only will the racking engineers have to provide assurances that the system will withstand wind load, typically a structural professional is also required to verify that the roof trusses and the roof structure can also withstand the extra dead load that'll be created by the ballast blocks. This strategy is very, very common in commercial buildings, flat roof commercial buildings. It's not as common in residential because most residential roofs aren't flat. But if you do have a flat residential roof, this can be a good solution if the roof is strong enough to manage the additional dead load. Okay, so here's some hypotheticals for you, which I've tried to um, apply a New Westminster lens to. So if we took this simple hypothetical single family dwelling that's undergoing an energy retrofit, and I think builders would call this a BC box. My house is a BC box, and I'm proud of it. But anyway, suppose we had this style of a house somewhere in New West, and the homeowner had done an energy retrofit. It was previously, natural gas furnace and hot water tank, and not very good windows. The envelope wasn't very tight, so some insulation upgrading was done, newer windows, etc. And following the energy retrofit, the energy advisor on the design team has estimated that the home will consume about 14,000 225 watts of electricity, in New West. And the question that is being asked is, so are there PV options that could help us reduce our ongoing operating cost? And so let's have a look at it. So if we, assume that, and I've made the simplifying assumption that this is a south-facing roof, that this is a south-facing roof, that this is an east-facing roof, and that that's a west-facing roof. Now, your situation might not be exactly like that, but easily assessed by a professional or by a homeowner using PV watts if it's oriented slightly differently. My example assumes these orientations. So let's suppose that we just use the south-facing rooftops that are available to us here. And it looks to me that like we could fit about 10.1 kilowatts on those two south-facing sections. Using PV watts, I estimated that in New West, this would produce about 10,124 kilowatt hours a year if those roofs were not compromised by shade. I haven't considered shading yet. And so that would offset, over 70% of the projected consumption after the reno. And that would be enough to, potentially get the homeowner really stoked. And then of course the question is, well, how much does it cost and is it a decent investment? Well, I've assumed, as I showed in some previous slides, that the average cost for residential solar in BC now is about $2.80 per watt. The system is 10,100 watts. So its estimated cost, I figured, was around 28,280, less the rebate, which is available in New West via BC Hydro. The net cost would be 23,280 based on your residential rates in New West and how much energy this might produce in New West. I estimate that it would take 14 years for simple payback. And so the compound annual growth rate for that is 5.08%. Compound annual growth rate is basically equivalent to GIC performance. So this would perform about the same as a 5.08% GIC, but it's actually better than that because these are tax-free savings. So you're not going to pay tax on those the way you would on a GIC. So some accountants would argue that this is better, depending on your marginal tax rate. This could actually be 6% or better, So, and in the first year, you'd save about a little under $1,500 in electricity if we, did this project in New West. Now, could we go further? Like, say the homeowner got excited and said, well, hey, what if I was hoping to try to get to net zero? Well, it turns out that if we also use the east and west roofs to increase the capacity to about 15.9 kilowatts, that we can produce in New West, and as long as there's no shade on these roofs, over 15,000 kilowatt hours, which is more than what the energy advisor is predicting for annual consumption. So we could get a net zero result if we wanted to. And after rebate, it would cost about $39,500, pay back in 15.8 years, and you can see the growth rate in the investment is not quite as good, and that is because the east and the west facing roofs do not work quite as well as the south facing roofs. And that's why when we're using the mixture of east, west, and south, our payback time is less, right? So that explains why that would be. But it's still a pretty decent investment. And if the homeowner has a motive of completely annihilating their electrical bill, then it would be possible. And so that's encouraging to know it could be possible. And that strategy would save in the order of $2,133 a year. Okay, so approvals and permitting, what sort of red tape is required to make a project like this happen in the city of New Westminster? Well, it turns out that the New Westminster utility will require an application under the Rate 500 program. They'll require a net metering application, which has to be filled out, and usually a solar provider will help you do that. And then New West electrical utility will review to make sure the design proposed satisfies their interconnection requirements. And that would they'd give you preliminary approval. So they'd go back and they'd say, okay, we're giving you the go ahead to proceed to building permit stage. And so then in the building permit stage, the planning and development department will require a building permit. Uh, they will possibly inspect. I don't know what their policy is on that. There may be an inspection by the city. And ultimately, if they're happy, they'll give you a permit, and you can proceed. So they'll come back with a permit, and at that time, your installer would take an electrical permit from Technical Safety BC. So your installer needs to have an electrical contractor's license to do that, because Technical Safety BC and the Canadian Electrical Code consider solar to be an electrical thing, which falls under electrical regulatory safety oversight. And so you will need to apply for that permit. Your provider will typically do that for you. And then once you have that permit, then the installation can proceed. And once the installation is complete, then your electrical contractor will call for a final inspection, and Technical Safety BC may or may not inspect. And then you will notify the city planning department that you have electrical go ahead from Technical Safety BC, final approval, and you will notify the electrical utility that you have that final approval. The city will approve your building permit. In other words, you're good to operate. And then the electrical utility will issue what's called final operating approval, and you can close the switch, and your system can begin to operate. So looking in a little more detail, the electrical utility rate 500 for net metering service falls under the basic electrical utility operation bylaw 6502. Um, they will allow up to a 50 kilowatt AC capacity solar system. And it turns out that the interconnection requirements have some simplifications if the system is 27 kilowatts or smaller. And this rate is available to all the single family residential rates, 101, 102, 103. It's also available to multi-unit residential customers, and it's also available to general service customers, business type customers. And in all cases, it's net metering, so the value of the energy that you might send back to the grid is the same as if you were to buy it, and the utility stores it for you until you need it. So one for one energy exchange. The utility has, by the way, these blue links here are live links. So once you have the slides, you'll be able to click on them and go right to these materials. The utility also has guidelines for interconnection and for operation of net metered systems. And basically, the requirement is that the equipment has to be certified for use in Canada. The installation has to be fully code compliant, and there needs to be a key point. There needs to be a lockable disconnection means that is accessible to the utility should they need to ever lock your system out of service. There's also a net metering agreement that the customer is required to sign, where you take responsibility for operating and maintaining your system. You have to provide proof of electrical approval from Technical Safety BC, and then after all of that, the utility will issue operating approval. In terms of approvals from the planning department, it turns out that a building permit is required. I am not certain of exactly what all those details are, we've been advised to suggest that you reach out to the building department to learn more and determine what next steps would be for your project. I can tell you that in many jurisdictions that structural assurances might be necessary. You might need to have a structural engineer sign and stamp drawings to confirm that the anchoring strategy will not damage the building and that it'll withstand wind loads. That might be a requirement. There might be additional requirements. I'm not certain, but in other jurisdictions, things like that are required, along with full sets of electrical drawings and layouts of how the solar will go on the roof and such. So in those other jurisdictions, these extra requirements, come at an extra cost. And so you'll want to make sure that your solar provider understands what the city of New West exactly requires. So it won't just be the cost of a permit itself. There could be other costs like structural assurances and drawings and the like. And you'll want to make sure that your provider includes those costs in their proposals when they're giving you pricing for potential installations. Um, the other good news is that there's solar and storage incentives available in New West via BC Hydro. So it's up to $5,000 for photovoltaic panels and inverters. It's $1,000 per kilowatt to a maximum of $5,000 or 50% of the total installation cost, whatever is leased. And similarly, there's a rebate for battery storage, up to $1,500 for battery storage, $500 per kilowatt hour, up to $1,500 maximum when installed with solar PV. There's also a statement here that you can install a battery-based system to back up some loads in your home. For instance, you could install it without solar, but it's not clear to me if that $1,500 cap applies in that case as well, or if the $1,500 cap only applies if solar is included. So that might be something that Sue and Ryan could clarify for us at a later date. How are we doing for questions?
Pretty good. Sorry. Um, we did have a question from Gavin, like talking about what should be, if you have any thoughts on for home batteries using repurposed electric vehicle batteries.
Um, I I personally don't think it's a good idea.
Mhm.
For one, you're not going to have a good sense of what the longevity is going to be. For two, they may not need unless they're certified to UL 9540, which is the certification that Canadian Electrical Code requires for stationary batteries in solar and PV, solar and storage applications. Unless the batteries have been certified by a vendor to that standard, your electrical safety authorities are likely to question it. So, if you want to go in that direction, you'll want to work with providers that may have taken repurposed EV batteries and had them certified to that standard. I know there's at least one company out there that was attempting to do that here in BC a few years ago,
Yeah.
but I don't have any experience with it. And what I have found is that even with batteries that meet all the required electrical code standards, we still run into trouble with local safety authorities that will question and and take time to satisfy. So I would personally tend to be a little dubious of how that might go unless you're working with a provider that has already worked through those certification challenges.
Nice. Yeah, that's some good guidance, Ben. Appreciate
Yeah,
it.
yeah.
I got one more question. Catherine is asking, and I guess this is gets into kind of community solar. Are you aware of any townhouse strata or mixed type strata undertaking solar installation projects in BC?
Yeah, we've done quite a few of them in the Kamloops area. In fact, we're doing one right now, which is uh, it's a low cost housing project for seniors, which it's effectively, I guess you could call it condominium development. I think there's 30 or 40 units. It's got a large flat roof,
Cool.
and we're doing a system on it to help offset shared loads like elevator and common lighting and all
Nice.
that, and common heating in the hallways, that sort of thing. Uh, yeah, so there are some cases of that happening, uh, and and as I mentioned earlier, because the New West utility honors net metering applications for multi-unit residential, I expect that could start to happen, especially for new builds in
That's a new build. She was asking, is this any retrofits as well?
retrofits. Yeah, it's viable. It's viable for retrofits as well, but it's more challenging. It
Hmm.
depends a
Of
lot
course.
on the way the metering systems are set up.
Yeah.
Like if each individual dwelling unit has its own BC Hydro account with its own meter,
Yeah.
it's more difficult than if it's a situation where there's a master meter
Of
and the
course.
building owner is selling the energy to the suite holders. That's a more tenable architecture.
Yeah.
And if utilities are going to get serious about making community solar on multi-unit residential buildings more viable, they'll have to start being more receptive to master metering configurations like that.
Nice. Yeah. Okay. More questions are coming. A good one from Trevor. How is the old PV panel recycling process looking these days? Anything local processing spent panels?
There's none that I'm aware of, I've seen news reports where people are starting to pitch it. I think I saw one happening in Alberta. I'm not aware of any in BC, but again, I'm sorry, I'm not an expert on where the industry is on the recycling piece. It's going to have to start happening
Totally.
in a serious way, and you know, but I think it takes some momentum. We have to have a large number of systems reaching end of life,
Yeah.
and
Turnover.
and,
Yeah.
and we're not there yet. Um, yeah.
Very good. Okay. Let's push on then. And
Okay. Excellent. Um, yeah. So I wanted to show some case studies. So these are actual real installations that I'm intimately acquainted with. This one in particularly, this is my house that you're seeing here, uh, and I want to talk about how it's worked here in the Thompson Okanagan, and then translate how that identical installation might work for a home in New West. So my home has a directly south-facing roof. The goal here was to completely eliminate my electrical consumption using a solar system. My house is quite natural gas dependent, and so my annual consumption of electricity is only about 7,000 kilowatt hours. So a 6 kilowatt system does it quite readily. It does about 110% on an annualized basis. I did this when the Greener Homes Grant was available, um, and so that reduced my cost. Uh, I have simple payback in about 12 years, and it's equivalent to a GIC at roughly 5.95%. Now, if we translated this project and put it on a rooftop on a similar home in New West with the south-facing roof, um, same installed cost after the BC Hydro rebate, the annualized production is lower because solar doesn't work quite as well in New West as it does here in Kamloops. And so the simple payback takes a little longer. Um, but the payback is not terribly compromised because your rates are a little bit higher in New West than we're paying here in Kamloops. But the compound growth rate is still like 5.7-ish%, and your first year of electrical savings would be about a little under $900. Here's another one, also in Kamloops. This client's motive was to try to take a big bite out of their tier two consumption. BC Hydro does have a tiered rate, which uh, applies to some residential customers. And so by retrofitting a 9.5 kilowatt system at a cost of about a little under $23,000 after rebate, this system will reduce their step two by 32% or 33% with a 32% overall reduction of their entire consumption. Um, compound annual annual uh, comp the compounding annual growth rate equivalent of 5.65%. The same project in New West um, would produce a little less energy. It only produced 9,300, so the growth rate is not quite as good, but not still not bad, and it would return about $872 of savings in the first year. Uh, this one is a net zero home, quite an extensive project for a new home we did in Kamloops a couple of years ago. Their motive was to fully offset their annualized consumption um, to achieve net zero certification. It's currently undergoing its 12-month test period to confirm that it has achieved that. Um, we used the south roofs. So there's two south roofs here. Then there's an east roof and a west roof to get 23 kilowatt capacity. We estimated modeled production of 25,300, which is more than the annual consumption. The builder used solar-ready trusses, and we used flashed deck anchors. Installed cost after the Greener Homes grant, which is what was available to this customer, um, was 59.4, a 13.3-year payback, uh, equivalent to a GIC at 5.35%, savings of about 36.82 in a year. And this home is reaching its net zero target. Um, in New West, if we did a similar project, same home in New West, annualized consumption would be somewhat less, but the same project would produce a little bit less energy because it's not as effective as New West. As Kamloops, about 21,800, a little under 5% compounding annual growth rate, and 3,300 or so savings in the first year. So still pretty decent investment. But in this case, it was a net zero target. So really, the customer was more interested in achieving the certification than necessarily saving money, but they've achieved both in this case. And this is what that install looked like. We used flashed anchors. In this case, we used black anodized rails for a better cosmetic look. Here's the panel starting to go down, and then this is what the installation looked like when it was finished. Um, this one is a case study out of Vancouver, and we were involved in this house. This is a very expensive home, which is built to the Living Building Challenge standard, which is beyond net zero. So not only does the home have to achieve net zero performance, it also has to be fully electric. There's no natural gas allowed. Um, Energy storage is compulsory because the home has to be able to sustain its essential loads for 7 days for a 7 day grid outage. There's rainwater collection and other tricks to reduce domestic water use. And there's also significant restrictions on the construction materials. And you could read more about the project on this link. So this is what that one looked like. Not only were there arrays on the flat roof, the east roof and the west roof, there was also an array on the garden trellis outdoors in order to get enough solar capacity to get to the net zero target. So there's a total of 23.5 kilowatts of solar. This is an example of a single line diagram, the kind of thing that you need to get electrical permitting in the city of Vancouver. And this is another second page of the electrical diagram, which shows the battery storage and the essential service panel, which is live at all times, even during outages. And included in those essential loads was strategy to charge an EV, even if the grid was down. So and the customer has made good use of that feature. This is what it looks like in real life. And here is where the equipment is all integrated. It's on an outside wall, which was subsequently covered with a roof, and there's barn doors to protect it from the weather. These are the three Tesla Powerwalls that provide the storage. These are the three solar edge inverters that work with the rooftop arrays. And this is all grid isolation equipment for separating from the grid as required. So how do we do this? How do we do this stuff well? Uh, Ryan, we have how much left? About 5 or 10 minutes, or?
Yeah, you got under five, and soon I got to do a quick wrap up in terms of the info sheet and program. So
Okay, so I'll blast through this quickly then.
yeah, no problem.
For best results, like avoiding the most common snags, don't leave solar as an afterthought. It requires careful design, and so if you're building a new home or planning a retrofit, get thinking about it early on. Don't wait till construction starts. It's very important to have clear motives. Why are you doing solar, and how much energy do you want to produce? What is that target? Otherwise, the goalpost keeps moving, and it's impossible to come up with a satisfactory solutions. So that's really clear. Choose your solar providers carefully. The lowest price does not necessarily give you the best results. And in fact, in many cases, it gives you the worst results. But I'll say more about that in a minute. Um, it's very helpful to become familiar with how these systems operate, some of the common terminology, and what your local authorities require, what the utility needs, what the building development department needs. And if you're happening to do a retrofit or a new build with multiple crews involved, discourage the providers from working in silos. They all need to be aware that it's a solar home. Otherwise, you can wind up with roof vents and plumbing stacks where the solar array should have gone, and that's a really bad idea. So, around choosing an installer, good advice from the Canadian Renewable Energy Association. You can check their member directory here and code of conduct. I highly recommend that you use someone that's a member of CanRIA. That assures a level of standard right up front. And then beyond that, you're going to want to get multiple proposals. Don't just get one quote, and make sure the proposals are all intended to meet that same clear motive that you've established. And that'll involve thorough site assessment, sizing systems appropriately to meet your motives, reliable, not exaggerated energy production projections, structural and electrical and roof impacts, all thoughtfully considered, shading accounted for, and engineering assurances and permitting and incentives, all included in the estimated cost. So there's no hidden cost later. Make sure that to check references, experience, and qualification. You're buying design and installation skills and experience and integrity. You're not just buying equipment. So you might be able to get cheap equipment anywhere, but if you don't have the other, you're not going to get a good outcome. Make sure that your provider is a licensed electrical contractor, that they have in-house engineering and design capacity, that they're well versed in electrical code, technical safety, and local government requirements. Ask for a project portfolio, find out how long they've been in business, how many installations they've done, and then do they have appropriate insurance coverage, and what is their warranty and aftermarket performance. So don't leave solar as an afterthought. You get bad outcomes. This is the one of the worst things that can happen here, where working with a solar ready builder that refuses to consult with the solar installer, and then you show up and discover they've got vents all over the south roof where the array was supposed to go, and the homeowner ends up being really unhappy. This is an excellent resource, the NRCan Planning and Decision Guide for Solar PV Systems, where you can follow like 10 steps to make sure you've covered all the important considerations, with your builder and your solar provider. It's a free download. The link is here. Um, CanRIA has a Go Solar guide that you can download here, and amongst other things, there's a section there on how to choose an installer. If you're really motivated, you might want to take the solar course that I teach at BCIT. Many people take that because they want to learn how to do this well. And then there you go, I'm finished. And so if there's any last questions, or if it's time to finish, I'll turn it over to Ryan.
Awesome. Really great presentation, Ben. It's awesome having your experience and knowledge on the on the webinar. Just a couple quick ones before we turn it over to Sue. Catherine, who was asking the questions about strata, she had one about any balconies, like any experience with balcony solar projects like they do in Germany, or perspectives on that, Ben?
Yeah, I've done one of those.
Okay.
In Kamloops, we did a balcony system on a net zero home where we had to use the balcony handrails for
Yeah.
extra solar capacity, but it was all structurally engineered because the railing had to be a lot stronger than if you were just supporting glass panels.
Yeah.
And then of course, it all had to meet electrical code, so there was a few hoops to jump through. I
Of
know
course.
there's some companies that are promoting easy add-on balcony solar that you just plug and go.
Yep.
I think utilities are going to a long ways off from allowing that just now. I'm hoping it'll come to that, but I don't think we're there yet.
Yeah. Okay. That's awesome. And then real quick one, typical lifespan of what you're seeing with panels.
It's not unusual to get 30 years or more.
Hmm.
Warranties are typically 25,
Okay.
performance warrant. And so I've seen panels out there that are 40 years old. I mean, they may not working as well, but they're still working. So it's not unusual for solar modules to outlast a roof.
Awesome. Okay. Yeah. Thanks again, Ben. That was a really great presentation and overview. Lots of good discussion in the chat, and really
Yeah.
appreciate you making time this evening. So we'll quickly finish up here, Sue, and I'm going to turn it over to Sue. We just wanted to cover off a couple program items. I think we got 2 slides or so, and then we'll let everybody out.
Yeah, okay, all right. Okay, thanks again to Ben for that great presentation. So we have a couple more slides. So I know that Ben gave you a great overview of the solar and battery storage rebate program. I just want to add a few additional stuff. So um so the rebate for the battery storage it it got decreased from $5,000 to $1,500 that from April 1st, 2026. And I know Ben raised a question that it was a little confusing, the wording on the website, but the battery storage must be paired with a solar PV system to be eligible for the rebate. It can be installed alone, but it's not, then it won't be eligible for the rebate. And also now Tesla battery products are not eligible. And also these are the like where you will have to apply for the net metering connection, and the product must be on the eligible system product list. And from June 1st, there is another requirement for the contractor. So when you engage a contractor, the contractor must be a member of HPCN. So to be eligible for the rebates. And for the rebate processing time, because the program is funded by BC Hydro and we require BC Hydro's approval before we can issue the rebate, it will probably take about like 3 months, up to 3 months following the interconnection. How to apply? So you can just click on this link when we distribute a copy of the presentation. So it's a combined application for net metering and rebates. So you just need to tick a few boxes for the rebates. There is one additional document that's required for the rebate application. That's the paid invoices. Okay. And
Sue, quick question before you show the info sheet. Trevor was asking if you install battery several years after solar, are you still eligible for the rebate?
yeah, you can add a battery system to the existing solar system. As long as it's paired with the solar system, you can still apply for the rebate. Okay, any other questions?
You're all good.
Okay. So we've just published a new info sheet on this solar and battery storage rebate program. So the info sheet looks like this here, and it will provide information on benefits of solar or and battery storage. And It also tells you about the process of net metering and rebate application. And on the back, where on the second page, it's got the whole section is dedicated to FAQs, frequently asked questions. So you can download a copy from Energy Save New West resources page. So the link is here. And I'll quickly give you a couple examples from the FAQ section. So multiple or combined rebates. So the rebates are per customer, per New West electrical utility accounts, meaning if you own multiple properties, you can apply for a rebate for each separate account property. And if you have multiple properties, multiple units within one property, you can still apply rebates per unit, but if the unit is within one building, then it's not eligible. So if you have any questions, you can just reach out to us and ask questions. Laneway houses, it's only if the unit is a primary residence with its own account or end meter. So if the units are connected to the main meter, then it's not eligible. When and how will I receive my rebate? So as I mentioned, it's going to be paid typically within 3 months after interconnection approval. And then payments can be issued either as a utility bill credit or as a check reimbursement. And there is also like there are more questions, Q&As on the info sheet. So yeah, we recommend you to check out our resources page. That was the last page.
And we're
So
gonna and Sue, I believe there's like we couldn't put all the FAQs on the info sheet, so there's additional stuff
yeah,
available
there will be
on the
additional
website
stuff
on
which we'll publish on the
website
city's
later.
website. Yeah.
Perfect. Okay. Yeah. I guess we'll wrap up. We yeah, went a little into overtime, but like really good content. Sue, thank you so much for pulling together the program stuff. Again, thank you, Ben, for awesome presentation and helping us out both on the industry side as well as on the on the resident side. Really happy to have everybody here this evening, and yeah, stay tuned to our newsletter. We'll be looking at doing something again in the fall. So if you have ideas, you know how to reach us. And yeah, we'll see you all again very soon.
Okay, thanks, Ryan.
Bye, everybody.